everyone. Next, we have ASP Isotopes Inc. It trades on the NASDAQ under the symbol ASPI and is a pre-commercial stage advanced materials company dedicated to the development of technology and processes to produce isotopes for use in multiple industries. Happy to welcome its CEO, Paul Mann. Welcome back to the conference today. We're looking forward to hearing your updates, Paul.
Great, yeah, thanks for having me, Anna. It's great to be back.
All right, the floor is yours.
Great, so we'll go for the presentation and then we'll go to Q&A afterwards in the usual format. So hopefully you can see the first slide now. So, we're a NASDAQ listed company, so please make sure you read our 10Ks and 10Qs and other filings with the SECs for a complete set of disclosures. So, we operate in three industries principally. The first is medical, the second is semiconductors, and the third is nuclear energy. And our goal is to build plants to supply all of these industries over the next several years. And if you look to the right, we operate in three verticals. So in the middle, you see ASP Isotopes, which is a company that produces stable isotopes. And we've constructed three plants in South Africa in that division. And those three plants are in the process of being commissioned and starting up right now. We'll talk more about those later on in the presentation. And to the left, you see PET Labs. And so PET Labs is actually South Africa's largest supplier of PET isotopes for nuclear imaging, so fluorine-18. And there's a real synergistic benefit between PET Labs and ASP Isotopes being in the same company, because PET Labs buys a lot of stable isotopes, whilst ASPI produces stable isotopes. And so there's a very symbiotic relationship there between the two. And to the right, you see Quantum Leap Energy, and Quantum Leap Energy is in the process of developing nuclear fuels for the future, and there's a poor connection. So great. And to the right, you see Quantum Energy, and that's going to focus on nuclear fuels for the future, specifically higher uranium and lithium-6 and lithium-7. And our plan is to spin that out at some point in the future. Our view has always been that nuclear fuels and nuclear medicine are very different businesses. And that business has signed two MOUs with two large US SMR companies and a term sheet with TerraPower, and also an MOU of the South African Nuclear Energy Corporation. And our goal is to enrich HALEU in South Africa. And we're making a lot of progress on that at the moment. So this chart just shows our goals for the next sort of 12 months or so in terms of operational milestones and our target milestones. And really, the key goal of this is to start these three plants up in South Africa, start generating revenues and start generating cash flows. And that should help, and then also start building new plants in the future. So a lot of people ask, what are isotopes? And when you think about different elements, different chemicals, hydrogen, carbon, and oxygen all have different numbers of protons in the nucleus, different places on the periodic table. And they're physically very different. Carbon is a solid at room temperature. Hydrogen and oxygen are both gases at room temperature. You can separate out these elements very easily using chemical processes. But some of these elements have different isotopes, the same number of protons in the nucleus, a different number of neutrons. And this means they've got different physical properties, identical chemical properties, but physical properties. So take carbon, for example. Carbon has three isotopes, one of 12, 13, and 14. And 12 and 13, we don't really find much use for, but it has particular applications in healthcare and agrochemicals. And our carbon 14 plant helps produce about 400 grams of carbon every year, and that's very valuable. So when you think a kilo of carbon, a kilo of charcoal, that probably sells at $1 a kilo. But a kilo of carbon 14 is more like $24 million a kilo. So, a very basic element going to a very specialized material that certain industries have applications for. Think about silicon, which goes into semiconductors. A bag of silicon has three isotopes, 28, 29, and 30. And, when you think about a kilo of sand, a kilo of normal silicon, that's probably $1 a kilo as well. But when we convert it to the silicon 28 isotope, it's about $500,000 a kilo. So again, a very basic element going to a very specialized material that certain people have applications for. I've always been interested in this industry because the supply chain has been so. This kind of slide here explains why. Russia's the largest supplier of stable isotopes to the world, and there's always been supply side problems, but those have been exacerbated greatly in recent years. So We have two technologies for enriching isotopes. The first is the aerodynamic separation process, and the second is quantum enrichment. And so the ASP process is basically a stationary wall centrifuge. So a traditional centrifuge used by Russia or Urenco to enrich uranium, these plants are huge. They cost billions of dollars to build. And they're basically a vertical tube that spins on a vertical axis and creates a vortex inside. And the heavier isotopes go to the outside, the lighter one go to the inside. Our plants are much smaller. They're scalable and they're modular. And we keep most of our components in the plant stationary. The only moving part is the compressor. And again, we can separate heavy from light by creating a vortex and sending these gases around various flow directors and valves. One of the advantages of our technology is that we can enrich light isotopes as well as heavy isotopes. So silicon-28, carbon-14 are challenging to enrich in a traditional centrifuge, which are actually ideally suited to our process. But the downside of ASP is a bit more energy for our processing. And so one of our goals is to start building plants in Iceland where energy is really cheap. Quantum enrichment is an advanced laser-based approach where we basically take a metal and we vaporize it, pass it through a laser, and that laser beam has been specially engineered and tuned to a particular isotope. Then we can ionize an isotope and we can remove it from that stream and collect it on a collector plate. So we built 2 ASP plants in South Africa and 1 QE plant in South Africa, and all 3 are in the process of being commissioned right now. This picture here shows a picture of our carbon-14 plants. On the left, you'll see the separators. In the middle, you'll see the heavy, and the right, you see the light element recoveries. And this plant is for carbon-14. So to summarize, our plants are cost-effective, they're modular, they're scalable, they're very environmentally friendly. There's no nuclear waste or really dirty waste that comes out of the plant. So let's talk about nuclear medicine now, the opportunity there. And so the nuclear medicine market is one of the larger markets we have access to, opportunity to compete in. And it's growing a lot due to innovation, new drugs, new diagnoses, and ways of treating new diseases like oncology. And this chart here kind of shows the symbiotic relationship between ASP Isotopes and PET Labs. So on the left, you see a bunch of stable isotopes that ASP Isotopes hopes to produce in the next several years. And to the right, PET Labs has the ability to convert those into radioisotopes that are used to treat patients with various diseases. Radioisotopes have short half-lives. You can only really transport them for a few hours. And so this really is last mile delivery. So our first medical isotope plant would be ytterbium-176, and that's in the process of being commissioned right now. And this plant uses quantum enrichment. Now, what's ytterbium-176? So radiopharmacies use ytterbium-176 to create lutetium-177. And lutetium-177 is the active ingredient in a number of new emerging biotherapeutics, radiotherapeutics called beta-emitting radiotherapeutics. And the most advanced and largest drug in this category at the moment is Pluvicto, made by a company called Novartis. And we've got a lot of interest in this from many customers. We expect to start shipping this product during the first quarter of this year. And we're currently in the process of just commissioning the plant right now. We're seeing good enrichment, and we should be ready to start commercial production fairly soon. The next isotope we think is of interest is zinc-68. And this is used to create a diagnostic called gallium-68. There's a range of new drugs called lutetium-actinium-based radiotherapeutics. And before a patient is treated with a lutetium-actinium-based drug, typically have to be diagnosed with gallium-68. And so there's a huge emerging demand for gallium-68, which has historically been supplied by a generator. And there aren't really enough generators to go around or to supply this excess demand. And we think the best way to make it is using zinc-68 in a cyclotron to make gallium-68. And so we've got a lot of interest from customers in this. We expect to start building our first zinc plant during the first half of this year. Molybdenum-100 is one of the larger markets we think is interesting, but it's probably more of a longer-term opportunity. And so traditionally, technetium-99 is the workhorse of nuclear medicine. It's about a $4.5 billion market. And that's made from molybdenum-99 that has a 66-hour half-life, so 2.5-day half-life. So imagine losing your inventory, halving your inventory's valuation halving every 2.5 days. It's a very challenging supply chain. It's fraught with problems. Now, technetium-99 can also be made from molybdenum-100 in a cyclotron at a radiopharmacy. We think this is a much better way to produce it. So, we think this market will take a while to grow, but we're ready to supply it as when we think the market is ready to take it. So the other medical isotope we think is interesting is carbon-14. This is quite a small market, quite a niche opportunity. And so we've signed a multi-year take or pay contract with a Canadian customer, which has a minimum value of $2.5 million a year. And this plant is also in the process of being commissioned right now. We've been delayed by a while for this plant because it was actually ready to start producing last year, but our feedstock is supplied by the Canadian customer, and that feedstock got stuck in Tennessee. So the feedstock has arrived in South Africa, and we look forward to starting this plant up in the next sort of several weeks or so. So this slide here just summarizes the opportunity in nuclear medicine, and what we expect to produce and when over the next several years. So semiconductors is one of the more exciting opportunities, we think, and certainly a unique opportunity for ASP Isotopes. So as I said earlier, silicon has 3 isotopes, 28, 29, and 30. And if you can remove the 29 and 30 isotope, or 29 isotope, then you can increase the conductivity of silicon by multiple folds, and also the heat transfer capabilities as well. And so a number of these advanced semiconductors used in AI chips are having real problems, staying cool and removing the heat from these chips. Also, for quantum computing, it's widely believed that you have to have silicon-28 at a very high level of enrichment. So we've built a multi-isotope plant in South Africa using the ASP process. And this plant is also in the process of being commissioned right now. And this plant will have capacity, we think, of about 50 kilograms a year of highly enriched silicon-28. We've signed 2 contracts with large US or global-based customers, one US semiconductor company and one large global industrial gas company. And we expect to start supplying silicon-28 during the first half of this year, of production starting up during the first quarter of this year. And this slide here just shows other opportunities in quantum computing and in advanced semiconductors. So we have a lot of demand for depleted germanium-73. So we'll enrich the 70 and 72 isotope, and also ytterbium-171 and barium-137 for quantum computing. And we're also looking at ways to create helium-3. There's been a huge shortage over the past several years. As I mentioned earlier, our ASP plants use a substantial amount of energy. And so one of our goals is to start building plants in Iceland in the near future. I went to Iceland just a few weeks ago to visit our proposed site where we're going to build the facility. And we signed the lease and started to talk to the government, and hopefully we'll start building there soon. And one of the advantages here is the energy is really cheap, less than 5 cents per kilowatt hour for a long-term 10-year plus guarantee. So this will make us, we think, the lowest cost producer of isotopes globally. We think this will be really, really helpful in terms of really driving down our cost of goods and being able to supply really cheap isotopes to the world. So let's move on to nuclear energy. Now, this is one of the most, this is the area of our company that gets most interest from investors. Well, actually, it's our lowest return on capital business, but it's certainly the largest opportunity that we have. And it should be fairly well known that the world requires a lot more energy between now and 2050. People believe you need to double the amount of energy between now and 2050. And I think a lot of countries have said they want to triple the amount of nuclear power during this time period as well. But you've got to remember, that's not really a tripling. For someone like the UK, that's actually a quadrupling, because its current fleet all become decommissioned over that same period of time. So it's a huge task ahead of the world to try and grow nuclear power by about what they want to. We kind of feel the future of nuclear energy is a small modular reactor, the SMR. And these are basically small production line manufactured nuclear power stations. So the traditional nuclear power stations are typically gigawatts in size. They cost tens of billions of dollars to build and take tens of years to build, and typically overrun on both timing and cost. Once you've built that huge reactor in the middle of nowhere, you've got to get that energy from the reactor to a population. So you've got to build a transmission grid that can also have all kinds of problems with the environment and environmentalists. So it's a real challenge to build these large power stations. An SMR is much smaller. For example, the exclusion zone around TerraPower's Natrium reactor is just 600 meters versus miles for a traditional reactor. And when you think about what made a car really cheap, it was the Ford Model T, taking a car into production line economics, production line manufacturing. Again, these are designed to be production line manufactured, so that really drives down the cost of producing them. And because they're much smaller, they can go nearer populations. Populations means you get the energy to the population far more easily. Some of the companies involved in this industry: Terra Power, which is Bill Gates' company; X Energy, that's Cam Garfassian; Arklow, which is Sam Altman; and then Rolls-Royce. And one of the problems with these SMRs is many of them require a new type of fuel called HALEU, high-assay low-enriched uranium. And currently, there's no Western supplier of HALEU. Now, when you think about traditional reactors, they use LEU, that's low-enriched uranium, up to 5%. HALEU is enriched up to 19.75%. And so a lot of these companies, these SMRs, have been delayed because of a lack of fuel. And we think our technology is the best for producing HALEU. Both our technologies are capable of enriching uranium, both ASP and quantum enrichment. But quantum enrichment we feel is most appropriate for it. And this chart here kind of shows the differences between various enrichment processes. So if you look towards the left, you'll see a centrifuge. And the important line here is the selectivity. This is how much enrichment you get per stage of enrichment. And so for a centrifuge, it's about 1.15. And you compound that 1.15 over a long cascade, and that gets you your desired amount of enrichment. To the right, you see three laser-based approaches: AVLIS, which is an approach tried back in the kind of the 80s and 90s, principally in the USA, and they achieved a selectivity of about 14, although they probably got a bit better than that in their later years. And then separation of isotopes by laser excitation is another approach that's being developed in the United States right now, and selectivity there is about 2 to 20. We find our selectivity is greater than 50, which we feel is, gives us a much higher level of enrichment per stage, and that allows us to do, a lot more energy for a lot more enrichment per unit of work. So, why quantum enrichment? Well, this technology allows us to do things other laser-based approaches couldn't do. So, for example, we can address atoms that aren't in the ground state. We can address quantum forbidden transitions, which don't normally occur in other approaches. And then we can shape the beam in a particular way, and a particular atomic vapor method that allows us to really drive, makes it a really commercially successful way of doing it. And this chart here just shows the only published real-world experience of quantum enrichment. This is published in our Chief Technology Officer's PhD. This is lithium-6 and lithium-7. At the top, you'll see lithium-6 feedstock. Lithium-6 is at 7%, lithium-7 at 93%. And after a single pass through our chamber, you'll see lithium-6 is over 90%, and lithium-7 is below 10%. So that's a light side enrichment factor of 112. So 112 versus sort of 1.15, that's a huge amount of enrichment. And what we said about a month ago, as we had our investor event here in South Africa, is that we've seen enrichment levels as high as 678 using quantum enrichment. And one of the problems with the nuclear fuel supply chain right now is all the prices are extremely elevated. We've seen 5-fold increases in some of these nuclear fuel supply chain prices. It's very rare to see a 5-fold increase in price and see no supply side response. We haven't really seen a supply side response in any of these industries yet. So what does this mean for the HALEU price if one was able to produce it? Well, if one could produce HALEU, you're probably looking at $20,000 a kilo plus. And when most of these SMR programs were planned, people were expecting to pay less than around $5,000 a kilo, certainly less than $7,000 a kilo. This will really challenge the economics, we think, of some of the smaller SMRs that are being designed out there. Now, what we're excited about with our program is that we think we can use quantum enrichment to take depleted tails and take it up to HALEU in a single step. And that would allow us to really drive down the cost of HALEU. And that would hopefully allow, SMRs and nuclear fuel to move into emerging markets where cost is really important to drive upkeep. And the answer to global warming is not more nuclear power in the United States and Europe. We have to drive green energy into emerging markets. And this is really important, and one of the things that gets our scientists excited every day. Actually, and this slide here also just shows other nuclear fuels we're working on: lithium-6 and lithium-7, and also chlorine-37 as well. So just to kind of summarize, we have a proven and proprietary technology. It's been developed over 20 years by our South African scientists. There are multiple secular and geopolitical tailwinds driving growth in our industry right now, both from supply side challenges and geopolitical issues, as well as emerging demand for new isotopes that aren't being supplied by any other producer in the world. So we've built 3 manufacturing plants in about 3 years, and we're very proud of that, and we look forward to them starting up later on this year. So Anna, I'll stop there and I'll take any questions.
All right, fantastic, Paul. Let's see, we've got lots of them for you. Sebastian has a few, starting with, what are roughly the prices for Xenon 129 per liter?
Yeah, we haven't disclosed that yet. We're talking to a number of potential customers for Xenon 129, and how we would structure that contract would very much depend on whether it's a tolling base for a current Xenon supplier, or whether it's a contract for someone who hasn't got any Xenon. But if this person's interested in Xenon 129, just contact us via email, and we can talk about supply agreement or whatever's needed. Perfect.
Have samples been sent out for ytterbium 176?
Not yet, no. We're still producing the intermediates for those, so they should go out fairly soon. We'll let everyone know when they do go out.
And what are your thoughts on the South Africa versus U.S. Trump political situation?
I generally try and avoid getting involved in commentaries around geopolitics. But what I would say is we found the South African government to be extremely cooperative and extremely helpful. We could not have built this business in the United States. We wouldn't have been able to get the skills and the manpower there to do it. The government has been extremely supportive in terms of giving us the appropriate licenses and giving us access to locations where we can do what we want to do. So we've had nothing but support from the government. I think the new government's extremely good. The coalition between the ANC and the Democratic Alliance, I mean, that's going to work really well. Since this new party took over in June, we've seen no load shedding. The roads are operating better, the traffic lights are operating better, and we're very impressed. I'm very impressed with what I see. And so, clearly what I'm seeing in the world is different to what the rest of the world is seeing on television.
And what amount of carbon-14 should we expect to be sold this year?
Yeah, so the carbon-14 feedstocks in South Africa, we kind of said it was going to arrive in January. We'd expect to start producing that fairly soon. And so, yes, we should expect that to get sold this year.
And could you elaborate on the PET Labs expansion strategy in the U.S. and in countries with a growing middle class?
Yeah, so PET Labs is actually one of the most exciting opportunities I think we have. So PET Labs is the only radio pharmacy in the world to be back integrated into the production of stable isotopes. And many radio pharmacies struggle to get hold of stable isotopes, particularly at reasonable prices, because PET Labs clearly doesn't. And so, one of our strategies is to grow this, particularly in frontier markets where we're seeing large population growths of middle-class people, and not a lot of radio medicine today. And also, there's opportunities to grow into more developed markets as well. I think to be successful in the developed market, you have to have either the lowest cost of goods or a differentiated product offering. And potentially, PET Labs can have both because of its back integration to stable isotopes, as well as some of the unique products that it produces in South Africa. So we're very excited about PET Labs. Watch this space for more news.
I'm going to do my best to say this comment, and please respond however. From a viewer, one comment from the Investor Day visit to Nexa was the willingness to work with many different countries. So do you consider the recent comments from the Minister of Mineral and Petroleum Resources on Iran to be rogue, part of a negotiating tactic by the government to encourage the U.S. to sign the Section 123 agreement, or symbolic of something more worrisome at SA government in parallel with the recent exploration developments? Can you comment?
Yeah, so I try and avoid commenting on geopolitics. This was actually an article in a newspaper where I thought there were some inaccuracies within the article. So I would view that as a rogue comment. I think what South Africa has said is they want to build 2.5 gigawatts of nuclear power over the next 15, 20 years. And there's been a lot of questioning over where they may get those nuclear power stations, who may build those nuclear power stations. And I believe they're considering both Russia and China as being the suppliers of those nuclear power stations. when I last checked, Iran probably was not capable of building a nuclear power station in a foreign country. So my guess is that's just a rogue comment or a misplaced comment. That's my assumption there. And then regarding the 123 agreement between the United States and South Africa, it certainly doesn't affect what we can do, what we want to do. So we're capable of shipping products from South Africa to the United States without a 123 agreement in place. The 123 agreement prevents us sharing technologies and information and of supply of other kinds of materials between the countries. It wouldn't necessarily affect what we want to do, which is produce HALEU and ship it to America. So yeah, I think there was some inaccuracies or errors in that report, which I read this morning as well.
And can you comment on the areas of overlap on the medical isotopes between you and Nexa? And same question on the uranium fuel chain beyond enrichment. Has Nexa asked if that's something ASP might be able to help with, given competing companies, or maybe offer a holistic package with collaborative agreement? What are your thoughts?
Yes, so in terms of nuclear medicine, I think there's a huge amount of opportunity for us to collaborate in nuclear medicine. So Nexa's got some very unique skills. They've got a source of neutrons at the Safari 1 reactor, and there's plenty of spare line time on the Safari 1 reactor. So we talk regularly to them about bringing new molecules and isotopes to market from Safari 1. And likewise, we've got some very good GMP labs and GMP manufacturing capabilities at our headquarters and facilities, which Nexa may not have. And so there's definitely an opportunity for us to collaborate on many things going forwards. And obviously Nexa is one of the leading, Nexa NTP, which is owned by Nexa, is one of the largest suppliers of molybdenum-99 in the marketplace. And so I think there's a lot of opportunity for us to collaborate there. In terms of other things on the nuclear fuel supply chain, we certainly talked about doing enrichment together at Pelindaba. And there aren't many locations in the world where one could build an enrichment facility quickly. Pelindaba has a lot of the requirements in place already in terms of permits. It's well known by the IAEA. The non-proliferation aspects are all taken care of. There's a very good workforce there that understands nuclear fuel. So that's certainly one area of collaboration we'd like to collaborate on. And we're talking right now about getting definitive documents in place so we can start working on that together as a group. And we're doing a lot of research in adjacent industries right now, adjacent isotopes right now, which will accelerate the accelerator. Maybe that's one of the reasons why TerraPower were keen to sign a term sheet with us, is because there aren't many plug-and-play locations in the world where one can build an enrichment facility. For us to build an enrichment facility in the United States, it's probably 10 years of paperwork before we put a shovel in the ground even. So I mean, this is it's a lot of the heavy lifting has been done already. And then in terms of other areas, there's a huge shortage of conversion right now. So that's converting yellow cake, U3O8, into uranium hexafluoride, UF6. And there aren't many people in the world with the skills to do that. We happen to have working for us a number of PhDs in fluorine chemistry. We have consultants and people working for us who have actually designed, built, constructed, commissioned, operated, and decommissioned UF6 plants. And so we've got a lot of skills in that end market as well. So let's see where our discussions with Nexa go over the next several years. But we're very excited about the number of opportunities in this industry. And
it was reported that ASPI has an MOU with OKLO. Can you address that?
Yeah, we don't disclose most of our customers. So I'd rather not talk about that. But listen, it's been widely rumored. It's been widely rumored in the press and in journals, and I think very highly of you. I think very highly of Oakler. I think it's one of the best SMR companies out there. I think they've got one of the best offerings, got the best business model. Very impressed with what they're doing.
And when will you release your Q4 full year financial report?
Yeah, so we have to file our 10K by March 31, so we expect to file it by then.
Perfect. We have a lot more questions for you, but we are out of time. Paul, thank you so much for joining us, and really interesting work you have, and we'll see you again real soon.
Thank you. Thank you for your interest.
All right, everyone, we'll be right back.